distance of 10 meters. Now, that 10 meters, if you think about that, 1 kilogram really is 1 liter of water. 1 liter of water is defined to have a weight of 1 kilogram. So if you lift 1 liter of water by vertical distance of 10 meters, incidentally, that's also the 10 meters. If you dive in the ocean to a depth of 10 meters, the atmospheric pressure will double to 2 atmospheric pressure. At the surface, you have 1 atmospheric pressure. At 10 meters deep, you have 2 atmospheric pressure. Okay? So that's also defines a pressure term that we're going to look at in the next exercise. So the next exercise we are going to do is that, for example, how much work is done to pump 1 liter of, well, it could be water, but let's just say it could be in general a liquid, from an enclosed vessel, creating a 1 liter vacuum inside. So what we're looking at here is basically the notion that I may have a vessel and I am pumping the liquid out through a pump, and I want to pump out 1 liter of water, but because it was initially full, but I'm pumping out the water out, and it would create a vacuum here. So the question is, how much work is done in that process? Now, actually, this is very similar to, and I can give you the answer right away, that it would be 100 joules, because that's equivalent to the amount of work that it takes to lift 1 liter of water, which weighs 1 kilogram, by a distance of 10 meters, which is exactly the depth you have to go down in the ocean by a vertical distance of 10 meters. Now, how do we do that? Now, I need to define a second term, which is pressure. And pressure basically would be equal to the force. So pressure is defined as the force per unit area. So if I have a weight of 10 meters of water, which has a exerting a force of 10 meters per second square times kilogram, or basically 10 Newton, that would give me this amount of force. Now, the second exercise I'm going to look at is related to the first exercise. I'm going to ask the following question. How much work is done to pump 1 liter of water from an enclosed vessel, creating a vacuum of 1 liter inside? So the idea is very simple. We may have a vessel that initially is filled with water, and then we need to pump it out so that as a result there is 1 liter of water coming out here, and then I would have 1 liter of vacuum. So the question is how much work the pump will have to do in order to create a vacuum of 1 liter inside. Now, there's another definition for work, and you can actually derive it. Work is equal to pressure times volume. So in this case here, the pressure that we have, 1 atmospheric pressure actually is equal to 10 meters of water exerting down on a force on you. So if you are scuba diving, you can go down a distance of 10 meters, and therefore you will face all that weight above you. And that pressure would be actually equal to called a pressure of 1 bar, and 1 bar is roughly equal to 10 to the 5th Newton per meter square. Pressure is defined as force divided by area, and the very fact that you have 10 meters of water and over 1 meter square, actually that exerts a total force of 10 to the 5th Newton. And because the area is 1 meter square at the bottom of that 10 meter column of water, so basically the pressure is 10 to the 5th Newton per meter square. Now, if I have to pump a volume of liquid out, which is equal to 1 liter, and we know that 1 liter is equal to 0.1 meter to the cube, because 10 centimeter times centimeters times 10 centimeter is a cube of a volume of 1 liter. So that's equal to 10 to the minus 3 meter. So if you look at the work being done here, then work is equal to the pressure, which is 10 to the 5 Newton per meter square, and then multiplied by 10 to the minus 3 meter cube. And what you see is that that is equal to 100 Newton meter. Again, a Newton meter is equal to joule, and that's actually the same unit, same amount of work that you need to do to lift amount of water up by a height of a height of 10 meters. So today we have learned this, which tie energy directly to gravitational force exerting on the mass that we have to lift up or pump a certain amount of water out.